Next example, evaluate the integration 0 to 1 integration x to 1 sine y square dy dx. That is here the order is with respect to y first, because this x to 1, this limit is on y, because this is in term of x. So if the limit is in terms of x, then it is on the y variable y, and the limit of y is in terms of variable. Therefore we have to integrate with respect to y first and then with respect to x, if we follow the order of this given. And if we have to change the order of integration, then draw the figure and take strip parallel to x axis in order to integrate with respect to x first. So that's depend on you. That is sometime the integration of this quantity with respect to y is complicated. Then we change the order. That is, there is a requirement of the example. That is a change of order is required in the example. And sometimes the problem is of that type, that change the order and then solve the integration. So if the question is change the order and solve the integration, means we have to change the order. And if the question is not in this example, there is just evaluate the integral. That is there is no question that change the order. But some example require the change of order. That is the its need of the example. That's because integration becomes complicated if the order is not changed. So this is such a type of example, that there is no instruction that change the order, but we have to change the order, because integration of sine y square with respect to y is somehow complicated. So that's why we have to integrate this with respect to x first. Okay, and that is we have to change the order of the integration. So first draw the figure. So how we can draw the figure? We can draw the figure by using the limit of the integration. That is this x to 1 is the limit on y. That is y is equal to x. So draw the line y is equal to x. This is the y is equal to x line, or x is equal to y. That divides the first and third quadrant in two equal parts. Y is equal to x line. Okay. Then y is equal to 1. So this is the y is equal to 1 parallel to x axis and passing through point 1 0 is the line y is equal to 1. Okay. And then x is equal to 0. Draw the line x is equal to this is limit on x now. X is equal to 0. So x is equal to 0 means y axis. The equation of y axis is x is equal to 0. And then x is equal to 1. So draw the line x is equal to 1. The line passing through the point 1. And so that point is this. So draw x is equal to 1 line. Okay. Draw here the line. And then the area bounded by this y equal to 1, y equal to x, then x is equal to 0, x is equal to 0 means y axis, and y equal to 1. So this is the area bounded by this x is equal to 0, means this y axis. Okay. And now we have to integrate this integration over this integral. Okay. So we have to change the order of integration here. So how we can change the order? So this is the given order, that is the y integration y with respect to y first and then with respect to x here. But we have to integrate with respect to x first. So take a strip parallel to x axis. So write this is equal to, don't write this is equal to, directly is equal to, no need of writing this also. So directly we write this is equal to, draw figure and then write this is equal to. So we have to integrate first with respect to x. So this is the limit on x. X runs from what to what? That is lower limit, upper limit, and y runs from to what? So take strip parallel to x axis. So this is the strip parallel to x axis. And its one end touches to the line x is equal to 0. So lower limit, the limit on the x is what? Is one limit is 0. And the other end of this strip touches to the this line, y is equal to x pro. So from this x is equal to y. So we have the two values. How we can write the two values of x? The strip ends, one end touches to the line x is equal to 0. So x is equal to 0 is the lower limit, and x is equal to y is the upper limit, because other end touches to the line, touches to the line x is equal to y. So y is the upper limit of the x. And then in order to cover this region, we have to move this strip from this point to this point. Means x runs from 0 to 1. X runs from 0 to 1. X, not x, y runs from 0 to 1. Y runs from 0 to 1. So in order to cover this area, we have to move this strip from this point to this point. Then this area, total area covered by this strip. And so y runs from 0 to 1. So this is the change of order. Actually, this is the next topic, the change of order. So if you have to change the order, suppose here the order is what? First with respect to y and then with respect to x. So when we have to change the order, means we have to integrate with respect to x first and then with respect to y. And in order to integrate with respect to x first, take strip parallel to x-axis. Okay, and then we have this limit, and then sine y square now constant with respect to x. So its integration is x into sine y square, or sine y square into x, because now integration is with respect to x, and then sine y square is now constant, becomes constant. Here the sine y square with respect to y is variable, and in order to find integration of sine y square is much complicated than this. So change the order, we have the integration this x into sine y square, and then x runs from 0 to y, and dy as it is, integration 0 to 1 as it is. This is the limit on y, actually 0 to 1. So lower value at the lower limit, value at the upper limit, value at the upper limit minus value at the lower limit. That is, substitute x as y, so we get y sine y square, and substitute x as 0, we get the answer 0. So lower limit value is 0. So value at the upper limit minus value at the lower limit is this y to sine y square. And now we have to integrate this with respect to y now. So substitute y square as a t, and then y dy is 1/2 y square. Derivative of y square is 2y dy is dt. Therefore, y dy is 1/2 dt. And then integration of sine t is what? Integration of sine t is and then limit is what? If you substitute y square as t, then y tends to 0, then t also tends to 0. Y tends to 1, then t also tends to 1. So limit are same. And then integration of sine t is what? Minus cos t, and then substitute t as y square. We have this answer, minus 1/2 cos y square. Upper limit, lower limit. Then value at the upper limit. Value at the upper limit is what? Take minus 1/2 as common, and then we have cos 1 square, that is cos 1, and minus cos 0. Cos 0 is 1. So write out of the bracket minus 1/2 cos 1 minus 1, or write 1/2 in out of the bracket, and then 1 minus cos 1. We have discussed. Next problem is sketch the integration region of integration and evaluate this integration. So first we have to sketch the region of integration. So how we can sketch the region of integration? We can sketch the region of integration from the values of limit. So the limit of x and y both are constants. So here the dy is first. So this minus 2 to 0 is the limit on y, and this dx is after the dy. So this 0 to 3, this is the limit on x. Okay. So y is equal to minus 2, right? Draw the line y is equal to minus 2. So y is equal to minus 2. This is the x-axis, y-axis, there is 0.00, and y is equal to minus 2 is the line parallel to, is the y is equal to constant is the line parallel to x-axis, and y is equal to minus 2. Therefore, below the origin, below the x-axis, this is y is equal to minus 2. Then y is equal to 0. Y is equal to 0 is the equation of x-axis. This y is equal to 0 is the equation of x-axis, is the x-axis. Then x is equal to 0 is the y-axis. This x is equal to 0. And x is equal to 3. This is x is equal to 3 parallel to y-axis, and at a distance 3, draw parallel line to y-axis. So this is x is equal to 3. So this is the black shaded region is the region of integration. Sorry. Then we have to integrate this. Then the limits of x and y both are constants, and so we integrate with respect to y or x first. It doesn't matter if the integration limits are constants, then we can change the order easily because of the Fibonacci theorem. Okay, so if the limits are in variable, then we have to change the order is somewhat complicated. But if the constant limits are constant, then easily you can change the order. But no need to change the order. We just integrating with respect to y first. So this bracket. Then with respect to y, integration means x is constant. The functions of x is constant. So x square is constant, and the integration of y is y square by 2 minus 2x constant. Integration of y square, y is y square by 2, 2 get cancelled. We have this. Then value at the upper limit minus 2 to 0. That is substitute y as 0, we have the 0 answer, and then y as minus 2. So minus 2 square is 4 by 2 is 2x square. We have this 2x square minus lower limit. So this term is minus, and this term is plus. Minus become plus. Then substitute y as a minus 2. So minus 2 square is a plus 4. So minus 4x is plus 4x dx. So write upper limit, value at upper limit, that is right in round bracket 0 minus value at this, and then we have this, and then its integration with respect to x is 4x integration is 4x square by 2 minus 2x cube by 3. Okay, and then 0 to 3 lower limit, upper limit, the value at the upper limit, that is substitute x as 3, and then substitute x as 0. If you substitute x as 0, we have 0 answer. And if we substitute x as 3, then what do we have? 3 square 9 into 2, 18 minus this quantity, that is 3 cube 27 into 3 divided by 3, again 18 minus 18, answer is 0. Next is sketch the region of integration and evaluate, same type problem, but here L and Y. So we consider next problem. Yes, sketch the region of integration and evaluate. So integrations are 0 to sin x. So these are the limit on what? These 0 and sin x are limit of y, because these are in terms of x, and 0 to pi obviously limit on x. So y is equal to sin x. Y is equal to 0 means x axis, and y is equal to sin x. So this is the graph of the sine function. It passes through origin, and this is the graph of sin x function. Y is equal to sin x, y is equal to sin x. Okay, these are the point of intersection. This is middle point pi by 2 pi. So the graph of sin x is this. Okay, so we consider the above part of sine x axis, because y is equal to 0 means x axis, and y is equal to x is equal to 0 means y axis, and x is equal to pi. X is equal to pi means this line. So the area bounded by all these four curves is this. Okay, so and this is the area, and then evaluate. So no need to change the order. You can also change the order of integration, but here is no there is no requirement of change of order. So don't change the order directly. We have, if the question is change the order, then change the order. Otherwise, in this example, there is no need to change the order. In this example, the previous example, this example, there is no question that change the order, but the change of order is the requirement of the example. The example is such a form that we have to change the order, otherwise integration becomes complicated. So in some examples, there is a requirement of example of changing the order, but if the or in some examples the question is that change the order and then solve. So Here is the only sketch the diagram and evaluate. Okay, so the diagram is this, region of integration is this, and now the integration with respect to y first. So it's y square by 2, because the limit of y is in terms of variable. So we cannot change the order of integration without changing the limit. If we have to change the order, we have to change the limit, because the limits are not in constants. The limit of y is in terms of variable. So first integration with respect to y is necessary. So y integration is y square by 2, upper limit, lower limit. So value at the upper limit is 1 half sine square x, the value at the lower limit is 0. And then its integration with respect to y is what? Substitute sine square as 1 minus cos 2x by 2. So 1 by 2 and 1 by 2 becomes 1 by 4. And then integration of 1 is x, and the integration of cos 2x is what? Sine 2x by 2. Sine 2x by 2, that's 1 half sine 2x. Then value at the upper limit, that is substitute x as pi 2 sine 2 pi. Sine 2 pi means sine 0. Sine 0 is 0. So value at the upper limit is just pi, and the value at lower limit is 0. So pi by 4 is the answer. Sketch the region of integration and evaluate, same type problem. So this is the order is u du dt. Du dt, that is variables are u and t. And then this is the limit on what? The limit on u, that is u is 0. U is 0 is the equation of t x is t, and u is equal to sine t. U is equal to sec t, so not sine t, sec t. This is the diagram of the u is equal to sec t, sec function. Then this is the limit on t. T is equal to minus pi by 3. So this is the t is equal to minus pi by 3. That is the equation of straight line parallel to u axis. I mean, u is equal to pi by 3 is this line. U is equal to t is equal to pi by 3. T is equal to pi by 3. So instead of x and y, here is the notation u and t. And then this is the region bounded by the four curves, and then integrating with respect to u first. So 3 is constant, and integration of cos t with respect to u is what? Now 3 cos t is constant, and its integration is 3 cos t into u, upper limit, lower limit. Then the value at the upper limit is what? Sec t minus sec 0. That is substitute u as sec t. Sec t minus sec 0. Sec 0 is 1. So sec t minus 1. And then its integration sec t. Cos t into sec t is what? Cos t into sec t is, and then limit is, lower limit is value is 0. Substitute u as 0. So sec t minus 0, that is sec t, and cos t into sec t is 1, because sec t is 1 by cos t. Then 3, and limit of 3 is integration of 3 with respect to t is what? 3t, right? 3t, and then upper limit, lower limit, value at the upper limit, value at the lower limit. We have answer 2 pi. So similar problem, evaluate this double integration. We'll discuss these problems in the next lecture.